Mellin transform of erfcx function. Okay, so I need to define both of these terms, erfcx function and Mellin transform first. Just in case if you are unknown to those things, we know that Mellin transform of a function f of x to the world of s can be defined as integral from 0 to infinity of x to the power s minus 1 f of x dx. Similarly, complementary error function of c of x can be defined as integral from x to infinity of e to the power minus t square dt, and this multiplied by 2 by root pi. Actually, the root pi by 2 is over here, and when taken to the other side, it becomes 2 by root pi. Yeah. Now let's begin. Okay. So this is integral from 0 to infinity x to the power s minus 1 integral from x to infinity e to the power minus t square dt dx and multiplied by 2 by root pi. Yeah. Now it's better if we just make these limits of integral numbers instead of variables. So what we can do is we can let y equals to t by x. That will solve the problem. So we have integral from 0 to infinity x to the power s minus 1 integral from now 1 to infinity e to the power, now that will be minus x square y square, and dt will be x dy dx. Yeah. Now let us interchange the order of integral. Yeah. And we have integral from 1 to infinity, integral from 0 to infinity x to the power s minus 1 e to the power minus x square y square x dx dy. Now what can we do is let us take this 2 inside. Let me write this as x square by s minus 1 to the power x square by s minus 1 by 2. There's a reason for this, doing this. E to the power minus x square y square and then 2x dx. I guess you have probably guessed the reason for doing that, because now if I let x square as g, 2x dx will just be dg, and so this is e to the power minus s g. Yeah, this is some s and this is some g, and then g to the power some value. So this is just the formula of Laplace transform now, and that makes the thing simpler. So we have now gamma of, what is the formula? Okay, gamma of this plus 1. So s minus 1 by 2 plus 1 by s is y square to the power this plus 1, that means s plus 1 by 2. Yeah. And then dy. I think I'm correct. Yeah. Now this is 1 by root pi. Gamma of s plus 1 by 2 can be taken out. We have integral from 1 to infinity of 1 by y to the power s plus 1 dy. Assuming that s is not 0, yeah, what we can say is that thing over here will be y to the power minus s by minus s from 1 to infinity, assuming that s is a positive number. Okay. Yeah. And so we get gamma of s plus 1 by 2 by root pi at infinity. This is 0 and minus minus plus y equals to 1. So 1 by s, and so the answer will be gamma of s plus 1 by 2 by s root pi. This is the answer. Whew. Yeah, that's the answer. And if you have to talk about the flaw of the problem, I use the definitions of both the things. Then we made the limits of integrals numbers, because that's simpler most of the time. We then interchanged it. We tried to take it to the Laplace transform form. We use Laplace transform formula, and then it was simplified a lot. And yeah, this was it. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.